we're going to focus on solving linear systems by elimination. So previously, we've solved systems by graphing two lines, and finding out where they intersect. And we would get an ordered pair like -6, 7. Then another way we did it is by substitution. We replace one piece of an equation into another. And so now we're going to think about elimination. Now, elimination means to remove or get rid of. I'm sure you can think of some other definitions. And so when we're eliminating, we want to get rid of one of the variables, one type of variable. Get rid of one type of variable. Just like in substitution, when we substituted, we would only see one type of variable. Either we'd see all x's or we'd see all y's. So in elimination, it's the same. So what we do when we do that is that we take a look at both equations, then we see whether we have terms with opposite signs. So let me give you an example. If you see 7x, then the same term would be a 7x, but it need to be negative. The reason why is because if you add 7x minus 7x, you get 0, and that would eliminate the x values. So if I had 3x, then I would need a negative 3x. I'd have to see that in order for it to disappear. If I see a negative 2x, I would need a positive 2x, because negative 2x plus 2x is 0. So let's think about another example. What if I had 4x and 4x? Now currently, if I added this together, this would not be 0. It would not eliminate the x. I would actually have 8x, so that doesn't help me. So what can I do to make it work? Now you probably remember that you can just multiply by a negative. If you multiply this by a negative, then 4x minus 4x now would be 0, and this would work. Now it would cancel. So these are the two types of elimination problems we will see here. One, we'll see it where they will cancel automatically because you'll see the like terms with opposite signs, or they'll be the same terms, but then you have to multiply by a negative in order for it to disappear. So let's try this first example. We have x plus 3y equals -2, and x minus 3y equals 16. So you take a look. Can I eliminate something if I add them as they are? So the x's, no, that would add together. That would not be 0. But looking at the y values, yes, 3y minus 3y would equal 0. So I can go ahead and eliminate as it is. I don't have to change it. So all you do is you draw this line like I did here. Not two, just a single line, and then just add straight down. Now remember, in front of the variable, if there's no number there is an invisible 1. As a reminder. So that means 1 plus 1 becomes 2x. Then 3y and minus 3y is 0, so that goes away. Then -2 plus 16, that is 14. Now this is just a one-step equation. We solve for x by dividing by 2. And now we know that x equals 7. So we have one part of our ordered pair. So do you remember how to find the y value? Yes, you substitute this 7 into one of the original equations, just like we did in substitution. So let's plug it into the top one. X is 7, so 7 plus 3y equals -2. That makes sense because we're trying to solve for our y value. So we subtract 7 from both sides in order to isolate the y. We get 3y equals -9. Then solving for y, we divide by 3. So y equals -3. So our solution is 7, -3. Now remember, if we try to graph this equation, we would find that that's where they would intersect. Now an important piece to this is that you do check. Check the solution in both equations. So let's plug it into the first one. We have x plus 3y equals -2. We want to plug in 7 and -3. So x is 7 plus 3 times our -3 times -3. Does that equal -2? Does that equal -2? So we're just checking. So 7 and then 3 times -3 is -9. Does that equal -2? And yes, 7 minus 9 is negative 2, so negative 2 equals negative 2, so far we're good. Now let's plug it into the other equation. X minus 3y equals 16. So again, we're replacing the x's and the y's with the 7 and the negative 3. So x is 7 minus 3 times y, which is negative 3, and that equals 16. We're going to see if it actually equals 16. So negative 3 times negative 3, order of operations, is positive 9. Does that equal 16? And yes, 7 plus 9 is 16, so 16 equals 16. This is correct. Therefore, the solution to this system is 7, negative 3. Now let's look at one more example. Here, we have 3x plus 4y equals negative 6, and we have 7x plus 4y equals negative 14. So in this case, if I try to add this right now, I would get 10x plus 8y equals negative 20. Now that doesn't work. I didn't eliminate a variable. I have x and y, and so that doesn't do me any good. So remember what I said before. We need to have the same exact terms, but opposite coefficients. So we notice that the 4 and the 4 is the same. So what we want to do is multiply one of the equations by a negative. So let's multiply the bottom. It doesn't matter which one, but I'm going to choose the bottom one. So I'm going to distribute this negative to every single term. So be careful that you do multiply to every single one to keep it balanced. So now this becomes a negative 7x, and negative times a positive 4y is a negative 4y equals negative times a negative 14 is a positive 14. Now go ahead and write the top. We're not changing it. We're just going to say 3x plus 4y equals negative 6. So now let's add these together. And yes, our y's cancel out, which is great. Now, 3 minus 7x, that becomes negative 4x, and the y's are gone, equals 14 minus 6 is 8, positive 8. So divide by negative 4, x equals negative 2. So we have our x value is negative 2. And now we want to find our y value. So we'll plug it into one of the equations. I'll plug it into the top. So we'll plug in 3 times x, which is negative 2, plus 4y equals negative 6. Again, I'm trying to find y. So 3 times negative 2, right, negative 2 from here, is negative 6 plus 4y equals negative 6. Let's add 6 to both sides. I get 4y equals 0. Now we still want to isolate the y, so we divide by 4. So what does y equal? 0 over 4 is 0, so that is our other solution. So we have negative 2, comma, 0. That is the solution to the system. Now let's go ahead and check. This is x, this is y. Plug it into one of the original equations in here. So this is 3 times negative 2 plus 4 times 0. Does that equal negative 6? So 3 times negative 2 is negative 6, plus 4 times 0 is 0. Does that equal negative 6? Why, yes, it does. So this is true. So far, so good. Let's plug it into the second equation. 7 times negative 2 plus 4 times 0. Does that equal negative 14? So 7 times negative 2 is negative 14, plus 4 times 0, that's 0, equals negative 14, and that is true again. So our solution to the system is negative 2, 0.